there's some new things to discover. Just leading up to recap the first step, we have here Jurjen Lenkijk in the room, who'll be able to show you about let's say the recap. So I'd like to hand over to Jurjen.
Yeah.
Thanks for having us at the IT Academy.
Yes, well, thanks for being here. So I go in this cockpit view. Very good. I have to look here, right?
Yeah, I can
this one.
Give you this one.
I don't mind. This one?
Nope.
Can people see me here?
Yeah, hang on. Almost good.
I only see the presentation. I don't see people's cameras.
Yeah, hang on.
Yeah, it's nice.
Yes, that one. Okay. Yeah.
Oh, we can see you.
Yes. So now you can see me. Hi there. My name is Jurjen Lenkijk. Welcome. I'm from the IoT Academy. The IoT Academy is a foundation which is set up by RDM Next, which is my company in KPN. And Software AG is our platinum partner in the IoT Academy. So already for 1 year now. And what we are doing with all the partners, because the IoT Academy, we have over 25 partners. All the partners are, we are all supporting the IoT world. So kind of telling the IoT evangelism to really spark innovation using Internet of Things. And we do that with workshops like this one. We have workshops at our place. We have workshops on other places where we go. We have an IoT education package with a curriculum, with a platform, which is provided by Software AG, the Cumulosity platform, which we're also going to dive into today, and all to get hands-on with IoT, and that's also the idea of today. But before we do that, first I take a very short recap of why we are doing this, why we are talking about IoT, and what are the main takeaways when thinking about how can I use IoT for my organization or my company. So why are we talking about IoT? We have seen in the last 10 years, roughly 10 years, an enormous increase in computational power. And that is due to Moore's law. Gordon Moore, one of the founders of Intel, told us in around 1960, when he founded Intel, that the amount of computational power of a computer chip would double roughly every 2 years. And a doubling every 2 years means that on the short term, the improvements are very small, but if you go further in time, the improvements will be huge. And well, if you look at this graph, this is a graph of the let's say the computational power of computer chips that hit the market, and then it looks like in the first 50 years almost nothing happened in computational power, and then in the last 10 years it went sky high. Well, we all know that between 1960 and 2010, the amount of computational power the increase was tremendous. I mean, if you look at a computer from 1980 and 2010, the difference is remarkable. Think about if you then look at the increase that we've seen in the last 10 years. Let it sink in how much computational power we have at our disposal today. And computational power means that computer chips, the increase means that computer chips become smaller, cheaper, and much more powerful. And those three elements have made the perfect storm for IoT. So today we are in a place in this world, in this day and age, in which IoT is perfectly set up for implementation and the use of IoT. First of all, we see that hardware becomes cheaper and cheaper. If you look at this, this is a Raspberry Pi Zero. I don't know if you're familiar with Raspberries, but they are small computer chips, small computers fully functional computers with the HDMI to put a screen on it, with USB to put a mouse and a keyboard, and then you have a computer which is capable of doing the same things as your desktop computer was capable of a couple of years ago, and that all on a credit card size chip, which costs well, if you look at this, it's 10-15 euros, and well, think about if you extrapolate that to hardware, how much cheaper hardware is becoming and how much easier it is to produce it. Second thing that is happening now is that we have much more communication ways to communicate. For example, we all know the Wi-Fi and the Bluetooth and the 2G, 3G, 4G, 5G is coming. But we also have a lot of different new ways to communicate on the other side of the spectrum. So low volume, low, very small data packages, which also consume less energy. So I'll come back to that later. So we have, for every use case, we have the specific communication platform to use. The third development is the thing that we're also going to talk about today is if you get that information from the physical world and you bring that through any connection to the internet, then you have to do something with that. And we are increasingly capable of juggling with the data. So really making value, making information out of data points that we retrieve from the physical world. And that means that we can really open up and really start using the value of IoT. And well, if you combine those three developments, then we are moving to a world where everything is connected, and everything that is connected has in some form these four different areas. So they all have something like a sensor. They all have something where they take something from the physical world and some information. And it can be anything. Then they all have something like connectivity. So getting that information to the internet. Then if you have it there, then everyone has to store the data and do something with it to really generate the value. And well, if you have it, then most of the times you want to do something with that data. So you want to inform people, or you want to make things happy. You want to open a window, or name it. And that is the last part. So these four elements can be found in any IoT implementation. So I'll dive quickly into these four elements. First of all, the sensors. So it's censoring, measuring something in the physical world, which can be a temperature sensor or a motion sensor, or much more sophisticated sensors which can sense gases or anything. But it can also be a camera, for example. And a camera is increasingly becoming a very, very powerful and versatile sensor. Give me your camera feed, tell me what you want to know from that feed. And if I can see it with a camera, then I can tell you. So it's increasingly easy using machine learning and deep learning methods to analyze images and get data from that. We have partners who are using that to detect damages on containers in the port of Rotterdam. You can use it to count the amount of people in a certain room. Just name it. Everything is possible. If you can see it with the naked eye, you can see it with a camera, and you can analyze it. And a computer, of course, can do that much faster. And if you train it well enough, it can do that with a much higher accuracy than we can. If you get into a Tesla and you put on the autopilot, that's exactly what's happening. The cameras is constantly the 8 cameras, the feed of that is constantly analyzed and built into an image of what's happening around the car and what is a safe place to drive. So getting any information from the physical world to the internet, but it can also be used the other way around to control something in the physical world. So if you have your information on the internet and you did something with it and you analyzed it and you want to do something in the physical world, like opening a gate or opening a valve or anything, that's also possible. So it's not only from the physical world to the digital world, but also the other way around, back to the physical world. So then we have our connection with the physical world. Somehow we need to get that data from the physical world to the internet. And for that we use connectivity. And there are roughly two different axes on which you can put the types of connectivity. The first is the range, so short range, 1 to 10 meters, let's say, and then nationwide covering and anything in between. And the other one is the bandwidth, and the bandwidth is how much data you can send over that connectivity type of connectivity. Most of the time, the bandwidth is connected to the amount of energy you use. Higher bandwidth, higher amount of energy use, because you just need more radiation. And here you can see a lot of different logos from a lot of different types of communication. And then on the right side, you see the 3G, 4G, 5G, Wi-Fi. Those are the really high bandwidth and in the G versions, the nation or even worldwide coverage. On the left side of the screen, you see things like LoRa, Sigfox, NB-IoT, which are all on the very small data packages with very low amount of energy. And those networks are also nationwide coverage, or it can also be implemented to just cover your own area. For example, if you have a large factory, you can put on your own LoRa gateway, and then you have your coverage on your own premises. They are typically used for very small data packages. If you have a LoRa sensor, for example, and you wanted to send 3 times a day the amount of water it measures in a well, for example, that with a small battery it can last for, let's say, 5, maybe 10 years, and maybe even longer if you have a high quality battery which doesn't drains over time. So it opens up new possibilities for IoT implementation. And then we have our information from the physical world brought to the internet, and we need to store it somewhere, and we need to do something with that data. And thinking about storage of data is very important if you set up your IoT solution, because it's very easy to just store it somewhere, but also that costs a lot of money. And if you don't do anything with that data anymore, your storage either becomes a huge burden on your balance sheet, or it becomes it becomes full, and then what do you do next? So think about from the start, what are you going to do with the data? What data do you need to store, and which data maybe you can analyze it and then store the analysis. For example, if you measure the amount of cars, for example, on a road, then you have a lot of data points that you are going to measure, and then those data points itself are worthless. They don't tell you anything. It's only the combination of those data points that are going to give you the value, being the amount of traffic on a specific time on that specific part of the road. So a lot of different data points combined together can give you information of 25 cars on this part of the road, which are traveling with a mean velocity of 53 kilometers per hour, for example. That is something that you want to know and that you want to store. So then we have our data, we have it analyzed, and Jan will explain this also further on in the presentation. But then, it's one thing to know it. The other thing is to do something with it and to bring it back to the user, to the customer, to anyone who needs to have that information. And that's the visualization and the application. For example, in the amount of traffic on the road, the visualization it shows you a map with the amount of traffic on, in this case, the ring of Rotterdam. And then the application is using that information to tell you the fastest way to go from A to B on this specific time of the day, and how much traffic jam you will encounter on the road. And well, that is IoT in its purest form. To conclude, some small remarks on what is IoT used for, mainly for two reasons today. First reason that we see most of the time is where is my thing? So telling where is my car, where are my assets, where is my the things that I rent out, for example. So really telling you where is it. And that can be an exact location, or it can be a almost exact location, and depends on what you want to do with that information. The other thing is how are you doing? So how is my thing doing? What is the temperature? What is the amount of heat that comes off this wheel bearing? Things like that. So really measuring the state of things in the physical world. That is where we are today. So we have all these developments going on. We are perfectly set up for IoT implementation of IoT. All the signs are on green. Where are we going in the next 10, 20 years? First of all, you will see that IoT will always be a part of the puzzle, a piece of the puzzle. So it will never be just an IoT solution. It will always be implemented in a broader data field of the data image of the company. It will always exchange information with other systems. So it's never just one IoT solution. It's always part of a piece of the puzzle. It will always be a convergence of technologies. For example, we are one of our partners is developing an autopilot for ships, also using cameras, for example, but also using lidars, also using information from the database where ships are telling where they are. So it's a lot of different technologies and a lot of different data points that are converging together to give an image of where the ship is and where it can safely go. You will see that in almost any IoT solution. It's never just measuring connectivity, and it's always a combination. The hardware becoming cheaper and cheaper will also keep developing, and one of the main interesting points in that is that producing for small amounts will be possible, and will be even more cheap. So right now, if you want to produce something, if you want to produce 100 pieces of that, the costs are much more than per piece than if you produce 10,000 pieces, and if you produce 100,000 pieces, it's even more. So but because developments in production technologies, it will become more easy to and cheaper to produce small amounts, and that is very important because any IoT solution, there's not one IoT solution which can be just implemented exactly in the same way in one situation and in the other. So there will always be some adjustments, some small changes, and analysts say we are not going to have one big winner in the IoT world. We're going to have 1 million markets with 1 million turnover per market. So the IoT market will be huge, but it will be a lot of very small markets, and that is very important when you think about developing hardware, but also software and your platform. It should be very easy to configure it exactly like you want it, because only then it will work. Well, and that will also spark the fact that we have a lot of different software vendors. We have a lot of different software data silos, places where we have our data, and it will be increasingly easy to connect all those different data points and combine them. And that's also what Software AG is doing. It's kind of a agent in between all those different software packages where everybody can provide their data, their information, and then at one place you bring it together and you really make the value. And then if we have all those information, all this data, generating visualization and really application is very important, because at the end you want things to happen in the physical world, and that is you need people to do that, or you need people to understand the things, the data, the information that you're giving them, and doing that in a visual, attractive way, and also in a way that people really get the information that they need and nothing more. Then that is also will also increase in the next couple of years. And to conclude, we just started. So we have a telephone, and right now we're telling you how to use the telephone, how it works. So we have a world ahead of us of possibilities, of new opportunities that we're going to grasp, and that we're going to really make value and make value, both in terms of sustainability and usage of all the resources that we have, but also in terms of your balance sheet at the end of the day. So with that being said, I want to give the floor back to Jan.
Okay. Thanks, Jurjen. Much appreciated. So thanks very much for the intro and for inviting us over here in this very inspiring RDM Next building. It used to be a ship dock, right? Yeah. Shipyard where amazing ships were built. Nice to be here and see what's good. So so just to get started, these people will be on mute if you don't. Yep. So I have to switch over a bit to see what's happening. You're still seeing my screen, if I hope.
Yeah, I can see the screen.
All right, and then so I'll have to switch over a bit. Just to take a moment to set up, or to reset up actually.
For some reason, I see your cell phone.
You see my cell phone?
Yes. I don't know how many cameras you have, but...
Yeah, I have a couple of cameras. That's correct. I was looking for that camera actually. Yeah. Hang on. Yeah, let me just, I need to switch for a sec. Yeah, I need this one. That's okay. So now, okay, hang on. Okay, this almost works. Just give me a second, guys. So yeah, okay, now you should be seeing me, right? Yeah. Okay, thanks, here. All set up. Okay, so yeah, I had to switch over a bit because we had to change screens, but looks like we're okay. Yeah, today, apart from the intro, it's really all about getting our hands dirty if possible. I've prepared a little hands-on, so we can follow a set scenario, and you'll be able to use your own device and log into our platform and take it from there. So before we start, let's do a bit of housekeeping. We have like if you want to interact with us, please use the chat box. It's probably used to it in the online world these days. We have, if you get stuck during hands-on, we have two people on the call, which are Misha Heuveling and David Becker from our team. We are all on the same team at Software AG, and they'll be able to help you out if you get stuck with small things, right? If you're really hopelessly stuck, don't panic. Just follow my lead. You can see what I'm doing hands-on, and you even after the session today, you'll have like, let's say, a week time to get hands-on and follow the scenario at your own pace. So it's better to if you really get stuck, just to sit back and relax and enjoy the show, and then we'll be back and we'll be able to help you out. Even I will join as well. So I hope for the hands-on part you will have your phones ready. Any smartphone will do, if it's Android or Apple iOS. Then, so what we will do is I'll explain about what the IoT platform is all about, connecting devices, doing data discovery, creating dashboards on the platform, setting alerts so you can communicate to the outside world, doing real-time analytics, and then also connect to third-party systems, to like business systems, to actually make use of the environment. So I'd like to explain a bit about the use case we have prepared. So today's scenario is all about a traffic sign, right? So we have this traffic sign, and so what happens if a truck backs up and topples the sign over? Yeah, we got a nice 3D graphics by our graphics department. No, okay, I did it myself. So what happens? The truck knocks over a traffic sign and leaves, and this is what it is. So nobody knows until somebody notices, and then 1,000 people notice it, and maybe one will call the city government and say, hey, this is a bent sign, you have to do something about it. So this is about the use case we have today, also in the light of the smart city scenarios that are popping up all over. This could be part of that, right? So normally what would happen, this would lay down for a long while, nobody would know, and that's it. So how can we solve this problem? That's what we're going to do today. So first of all, what we do is we're going to add a sensor to the sign. In this case, we have like a tilt sensor, so it will know if it's straight up or it will be toppled down. And then next one what we'll do is we connect it to the internet. So really, Internet of Things, so it makes sense, right? So as soon as it's connected, we can do something with it. So that's also where our platform comes into play, where we have this smart traffic sign, and this smart traffic sign gets connected to the IoT platform, right? So this is what's happening. We have Cumulocity IoT, which is our platform. We can do all the things I told you earlier about, like connecting devices, doing data discovery, analytics, alerting, anything goes. So let's say we create an alert whenever this sign falls down, and then we'll take it from there. The alert would be able to be shared with the outside world using any kind of integration platform. We'll use our WebMethods.io, iPaaS, cloud-based platform today, and then you could make sure the outside world knows. In this case, we have some incident management, let's say service management tooling, where somebody would be able to instruct a mechanic to go out and fix the sign. And then to finish the whole scenario off, the sign will get fixed, the incident will get resolved, and again, the integration will make sure the alert gets cleared. So that's kind of the end-to-end scenario I'd like to share with you today. So if everybody's okay, I'd like to get started. So this is about the most slides you'll see of the day. I have some other stuff to explain, more of the analytics scenario later on, but I think it would be good to get started straight on. So yeah, just a short introduction to the platform. What are we going to see? So this is just a one slide showing we have on the bottom, we have all the device connectivity. So this platform should make it easy to connect any kind of device, right? You're in explaining about the different ways that the IoT device can communicate, different methods, from local LAN type connections to small sized narrowband connections, for instance. So that's all about connectivity. It's all about a way to get data into the IoT platform, basically. That's all about this lower part, how to manage your devices, and that's it. Then doing the data and analytics, we'll cover that for sure. Then using the integration capabilities to connect to the outside world, create applications for visualization, and even we have like accelerators which use like which have a preset solution for a well-known problem outside, like water management or smart buildings, this kind of scenarios you could think of. Yeah, we can deploy the platform on cloud by natively, but also on premise or even on edge, which is more and more to keep the data local to where the sensor are. If you have like high volume information, you keep the data close to the sensors, so you'll have less bandwidth to use on the internet, right? So that's usually a lot cheaper, and you can digest a lot more data for your whole ecosystem. Okay, so I think we're about good. So much for the presentation. I will now switch to my screen here, and what I'll do is I'll check out on the environment. So normally, if you have your, I hope you in the instruction you've already seen the way how to download the application. If not, I'll quickly show. That's not happening right now. Hang on. I was going to show you the the sensor app. So normally onboarding on the platform, you'd be able to have like an onboarding routine. Unfortunately, in the setup we have today, this part of the cockpit is missing. So we don't have this application. So you'd normally be able to take your phone, take the camera of your phone, scan this QR code here, which would take you to the App Store or let's say the Android Store marketplace for Androids, or App Store for Apple, and it will be able to you'll be able to download the we call the Cloud Sensor app. So it's an app we did it specifically for our platform, and it will turn your phone into the sensor. So just to give you an example, so what we actually do is this whole smart traffic sign we have created will be turned into, so we'll use the phone to do this, right? So phone already has the sensors, we have the internet connectivity, so everything is covered, and then the sensor app will be able to take those sensors and communicate them to the platform. So if you have this app downloaded, yeah, so please do so. You can't scan the code. You can look at the marketplace or for the Cloud Sensor app and download it. If you get stuck on this part, this is typically where you'd involve guys like Misha and David to get you going. So I've already done this, and so I will now. So what you can do is I'll paste the login information to the platform in the chat box. Yeah, see if that works. Hang on. Yeah. So now, if you look in the chat box in Teams, you should be able to find a link which takes you to rdmnext.eulatest.cumulosity.com. Right, so that's where the website is. Just to give you an example how normally the onboarding would look like, I have another environment here. You'd see this. You could add a device. You could add a smartphone and take it from there. But we don't have that right now, so we'll stick to just downloading the app. Now, if all goes well, I have a screen which shows my phone, which of course doesn't work right now. Yeah, that's happening. Hang on. So if you've opened up the phone, so here you see a live screen of my phone. I also have this in place. So if you then connect to the platform, you can do. The name is RDM Next, right? Which is the local environment we have here, or the local cloud environment actually. And if you want to select a domain, it should be eulatest.cumulosity.com. To give you like a drop-down box of options here. So if you type that in and you do connect, that should take you to the login screen. And there you have the user ID and password that are in the chat box. So that's, I'll type along with you. So that would be workshop. And the password would be July with a capital J. Dot 2020 2020. Okay, that should be it. If you then log in, it's registering the device and it shows you the next name. Or I know on iPhone it looks a bit different, but here it would be good if you just modify this name a bit so it's personal. So let's say I do JVDL, so it's my my credentials here, my initials. And then when I save this, it will have connected to the platform. So I'll be able to show you. But just by the way, if you get a question, you want to share your location, yes or no, you can choose not to do this. But it's it's normally fine if you want to share a location. I won't zoom in on any specific location, so your privacy is guaranteed in that sense. But it's not really necessary for the rest of the hands-on to share your location. Okay, so now this is done, we can do the first bit of data discovery on your sensor device itself, right? So I'll be able to show you what's happening here. So I have this on screen where you actually see the same phone you're seeing on the screenshot. And I can do view sensors just to see where I am. So here's the location. This is the RDM Next building. I'm right in the middle of it. You see my Wi-Fi strength, and you see some other interesting sensors that we'll use, so acceleration, gyroscope, magnetic field. So depending on the type of device you have, you may or may not have all of these, but it's really important that we use some of them. So remember, this is supposed to be a sensor that was stuck to the traffic sign, right? So let's say we stick it to the base of our traffic sign, and so if it's laying flat, it's okay. And if it's then topples over, that we should have like an alarm situation, because then the traffic sign is down, let's say. So we're looking for a sensor that changes over time. If I move my device, or if I tilt it, what you see is that the actual yellow line here, which is the Y measurement from the accelerator, goes to 10 and to 0. Right now, I know on iPhones it's a bit different. It goes to -1 and back to 0 if it's flat, but that's it. So actually, this is quite a good sensor for us to use, and we'll use that later on. So much for this. So if you have this running, or if you just see me having this running, that's fine. Actually, this is all we need to do for now. We don't really have to check on anything else here. So I'll just go back to my main screen. Stay logged on, so the data will be sent to the platform. So first thing I'd like to do is to show you how this then looks in the platform. So you can use this login credentials in the map to go to RDM Next EU latest. I hope this works. If it doesn't work for you, again, reach out to Misha and David to get you logged in. If it really fails, again, fine. Just look at what I'm doing, and you can also rehearse that at a later stage, or repeat it at a later stage, I must say. So what happens is that in a phone, okay, you see, I can see that people are really already connected. So I see Damien and some others. So so it's nice that all of you have joined so far. So I see that it's been successful. That's a good sign. So what you can do first is to go and find your own phone. Now I'll use mine for now. And what you'll see is like a standard dashboard. So you'll see my location again and some linear gauge for some value. I know it's already the G-force and it's out of range. It's fine. We really don't need all of this because we're going to create our own visualizations. So what's important to see is that normally, so we have done like device connectivity now. Next thing we'll do is to do some data discovery. Right, you've seen the visuals on the phone app, which is cool, and now you see the same data actually represented in the IoT platform from here. So again, so you see my device, and I see all this accelerator, barometer, blah blah blah, all these interesting values that are available. So we already, if you remember, on the phone application, you saw that the Y acceleration really represents the tilt of the device. So this is actually the only measurement we're going to use out of the many measurements we can get from the device. So that's it. I'm just going to add it like this. And if I then, you can see the real-time representation of this data. And what I can also do is to show you this in a bit more tight time window. So what I could do, I could do like a custom and select this time window, or I could say, okay, I always want to have the last minute of data. So any data in the last minute will be shown here. So again, if you look at my visuals, if I pick up the phone, you should see this real-time data change over time, which of course didn't happen because I didn't switch on the real-time thing. Okay, so real-time is important here. This means it will actually monitor the data. So if you haven't got this enabled, please select it. You should be good. And then, so what you'll see happening is that, right? So I move it up and down. You see the values change in real time. So this verifies that this sensor is the right sensor, and the whole of the IoT device is connected and capable of sending measurements to my IoT platform, which is already a big thing, right? We did this in like 5 minutes, and it's like, I think this is really powerful to know that it's this easy to really connect your hardware. So just to give you another side step here, so normally what we do if we have like a workshop here internally at the IT Academy, we'd use much more low-cost device, and obviously the so phone is a very expensive piece of equipment. So here at the IT Academy, we have this kit. It's called the Marvin kit. Right, you see on the left, you'll see your power bank. Then you'll see a Marvin, which is actually a controller board, which is capable of sending data over LoRa network. KPN LoRa network is used in this context, and it has the capability of connecting all kinds of sensors. So you can create any kind of interesting project use case with this. So this is normally the way we do it if we'd be able to invite you over to the IoT Academy itself. So for now, we'll just stick to the phone and it's fine. It's good to see that we all got connected. Right, so this is it. So this is really all we need to do on the data discovery part. Normally what you'd have, you have a much more complex situation. You have multiple devices, multiple measurements coming in, and you like to make some sense out of it. This will take a bit longer to really pinpoint the right kind of measurements to use. So for now, this is okay. And I think it would be good to switch to the next part after data discovery, which is the actual dashboarding. So how to visualize this data So it makes sense to anybody, let's say in the operational space, to have like an operational dashboard to use. So for this, I'll switch. You can see the plus sign on the top right of the screen. You can do Add Dashboard, and you get to the new dashboard screen. So let's personalize this a bit. So this is Jan's phone. Or if I be able to type Jan's phone dashboard. And that's it. And you can have like an icon to the dashboard because it will end up in a different tab. Now, let's say this is an Android device, so I'll take the Android logo. You could do an Apple one, Jurjen, if you're following. I think I'm in a corner of my eye, see Jurjen doing the same thing. You can have like a theme to it. So I like the darker theme because it fits better to the IoT Academy layout. You see that we have like a personalized environment of the IoT Academy here, with all the branding in place. Everybody could do this for himself. And that's it. We don't really have to do anything else. So now we have Jan's phone dashboard, which is an empty dashboard and doesn't do anything yet. So first we're going to do is to see if we can find a representation that kind of fits the level of tilt we want to show. So we can do an add widget here. And there's a whole list of standard widgets available. Obviously, if you're going deeper, you can have like custom widgets added to your specific environment later on, but it's not for now. This really, the aim of today is to really use a standard platform, so anybody can do this. And what I'll do is I'll take a linear gauge. So you can do this search here and tick LIN in the box. You see linear gauge here, and that's it. So you can have a title to it and saying, so this is like phone tilt. Okay, and then you have to select a data point, and which is the same acceleration I kind of added on the data discovery part earlier. So this is kind of list that you created, or that you saw from the available measurements. You limit it to the ones that make sense to you for now, and that's the one you can select for your dashboard. You can always add ones later. That's fine. So this is it. So let's say we do this and we have it in a standard fashion. What you'll see is you have like a 0 to 100 thing. And if I tilt my device the wrong way around, let's say tilt it downwards, you'll see that it goes to a negative value and it's really out of range, right? So you see the value out of range. Tilt it up again, you'll see that it goes to a 10, which is really out of range. So it doesn't really matter too much. It's not really nice representation. So what we can do is we can actually change this phone tilt one. You can follow if you like. So on the top corner, there's the settings icon here, and then you can do edit. And if you then look at the same representation, you can click on the data element here. So anywhere on the text acceleration, and there you can change this, right? So I will do a minimum and maximum one here. So you see it's the name here. We're going to change this as well. Let's say acceleration Y, because we could have like Y acceleration. See, I've done this before, so I don't have to type it. And the minimum value for me would be like a 0 or like minus 10, because that's the lowest point, and plus 10, which is the maximum. Take note, if you have an iPhone, this will be -1 and +1. Right, so this will be your range, and it will look differently. So Jurjen, you have an iPhone, right?
Yeah.
So okay, so I'm going to be looking at what Jurjen is doing to verify this also works on the iPhones. I've been doing this before, so it should be good. So I'm going to save it like this, and then what you see like a level in the middle. You see it immediately is like a balance. So if I tip it over the phone, let's say to the wrong side, it goes to -10, and upside it goes to +10. So really, I've calibrated the visualization, if you like. It makes sense, makes much more sense now. Same thing we can do is on the data. Let's go back into edit mode. You can set like the thresholds for the visualization. So we know a certain level of tilt will say, okay, this traffic sign is bent too far up or down. So you can have like a yellow range and a red range. So if it's like a yellow range, it's slightly toppled, let's say. Let's say I will use 5 to 7. So the iPhone users would like use -0.5 and to -0.7, which is a bit strange. You should start with -0.7, by the way, because it's the lowest. So you have minus 0.7 on the lower and minus 0.5 on the right. Our Android users will be able to use like this. And then the red range would be like 7 to 10, which would be like -1 for iPhone users to minus 0.7 on the iPhone users. I see Jurjen does this, so I assume all of this goes right. When I save it now, what you'll see in the visualization is changed to like a yellow area and a red area. So this one is still just for visualization, though it doesn't do anything yet. But you'll see like in a visual, okay, so this is getting close to be too far tilted. And if you tilt it even further, it goes to the red zone. So we're going to use these threshold levels to create alerts further down the road. Right, so this is what it's going to be like. Okay, so having seen that, if you like copy this representation, so you don't have to follow this because we're going to change this in a bit. Let's say I'm going to do another type representation of the same thing, and I'm using a silo here. So again, you don't have to do this. You can, but it's not mandatory. If I then do this again, you'll see the same thing that happened to the horizontal bar will happen to the vertical bar. It has a wrong scale and it doesn't have these thresholds in place. So what we can do is we can go back, and if it's really data oriented, which it is in this case, we can also change it on the data level, and then whatever visualization comes next will adhere to these standards, right? So I'm going to get rid of this one, and we're going back to Data Explorer just to change it on the data level. All right, so having done that, we go back to Data Explorer. We'll see this point. And what we'll do again is here we switch the name to a more readable version, Y acceleration, minimum levels, -10. So it's -1 for the iPhones, 10. We do the same thing we did on the visualization earlier, right? So yellow range 5 to 7, and then 7 to 10. Again, iPhone would be -0.7 to -0.5 and -1 to -0.7 here. And that's it. You can also change the color here if you really want to. I can make it a bit more flashy. Fine. And be done with it. So this is what we're seeing now. So now going back to the dashboard, we don't have to save this. This all gets automatically saved. If you, let's say I get rid of this one, you don't have to do this, but you can. And we add another linear widget again, just like we do it from scratch. Linear gauge, and we see already it's a blue thing. It's called Y acceleration. So this leads us to think that this all went well. And immediately you see the right representation, right? So if I then add another one, for let's say a radial gauge, why not? While we're here, and we use the same acceleration thingy, and then we'll save it. What you'll see is you see the same things on another representation. So if I now tilt my device, you see that it looks like this. So this could make sense, much more sense to other kinds of measurements. If you want to have like a dial, you can do it like this. Okay, so I'm going to get rid of this dial because we don't need it. So this is really the basics about data and interacting with dashboards, and that's all cool. So now you may also want to have a bit more historical view of the data. So what we can do again, we add a widget, and we have like a data points graph. There it is, data points graph. We'll just leave it as default, and you see it. You see the data, historical data, over time here. Same as with the Data Explorer, you can also set the last minute thing to have like the real-time information here. Switch to real-time, it's all the same thing. And now you'll see over time what I've been doing so far. So instead of just having the operational actual value, you should also see the historical value. It's good because then you can see what has happened. Okay, so I hope this has been clear so far. If this is all good, we've kind of concluded the basic dashboard part. Okay, so what you can do is you can also interact with the device, right? We've seen that there's possibilities to to also say that you could, so if something occurs, you could have something done, right? So it could be that, if there's like a communication failure, you could like restart the device automatically. Or if there's a security breach, you can shut down certain systems based on any sensor information. Anything would go, right? And it's all relating back to the device. You can even update firmware if there's a firmware fault to fix a certain issue. You can also do this remotely from the platform. Just to give you a quick view of something that could be done, you can do this for yourself as well if you like. There is a way to send a message to the device. So this specifically, if you say message sending, you'll see another widget popping up, and make sure this is your device here. Well, you're in your device's dashboard, so that should be fine. So now what would happen if I'm here in my if I'm here in my app? Let's see if it's still real time. Yeah, we're good. And I'd say let's say in an easiest scenario, this phone is being picked up here. I would be able to say, okay, hey, please put. I'll just keep it short. Put it down. Put your phone down. Okay, I'll send it. And what will happen is here is that you'll see in my app that please put your phone down. It's happening. So just to give you some idea, so again, from the cloud platform, this platform knows where the device is, knows how to communicate to the device, and the device takes action based on what you send it, right? So you could have like configuration parameter send, calibration of online, from remote location, anything goes. Just to show you can have like a simple interaction. Then what happens, I'm going to put my phone down, and I can say, okay, obviously I have to click here on my phone, and I can say, this is like, we talked about this earlier, didn't. And so I can say thanks, and that's fine again. So I'm going to click OK and not on my screen. So this is just to give you some kind of idea. So we could leave this in. It's not really something we're going to use in the rest of our demo. So I'm going to get rid of it right now, just to clean up some space on my dashboard. Okay, so having done this, the way to automate stuff is to really start creating alerts around certain values. So the easiest thing you can do is to have something that's called a smart alert. We'll go into more details later on. Sorry, I'm stuck a bit here. Let's say we take it from the data point here. Gonna edit this. We have Y acceleration as a point we're using. And now we want to create an alert if it goes beyond, let's say, the red level, right? If it's in the red zone, this is when the alert should take place. So what we can do is we can take it from a data point that's shown in any widget, or we can take it from a data export. It's the same thing. And we can say, okay, create smart rule from this parameter. If you click on it, you'll see smart rules that are like preset rules. Easy, it's like standard recipes for alerts, if you like. And that can actually make sure that you do that you can create an alert based on something. So what we'll do now is on measurement, explicit threshold, create alarm. We'll say it's a rule name, and we'll say create alarm when a phone is picked up. It doesn't really matter, it's just for aesthetics, this one. The data points, everything is already set. Only thing you need to do is make sure you use the red range, which is again 7 and 10 iPhone users will have like -1 and -0.7 here. And this is the important bit for us because we're going to use other automation based on this. So if you have to really make sure this is right. So this is called phone pick up in this session, right? And then there's text that could go, and because it's my phone, I say Jan's phone was picked up. This is just like a description of what's happening. Or you could say traffic sign was tilted if you want to stay within the scenario, of course. Okay, so that's it. Once we've done this, we'll have, we can cancel out this because we didn't change the widget, by the way. We'll have an alert definition. if you look at the alarm section, nothing's happening. And then if I pick up my phone, you should see my alert. Jan's phone was picked up in the alarm section. You can do this yourself, right? Should be okay. So just to show you a bit, I'm putting it down again. What's happening is that we now have a smart rule that is triggered here. It's the same thing we just defined. You can also temporarily disable an alert. So if you know you're going to have like maintenance on a device and you don't want these alerts to go off, you can disable them from here, right? You can just switch off and switch on alerts. I'm going to leave it on now because we're going to add this information to our dashboard now. So going to the phone dashboard, we can add another widget, which is about alarms. So if you do a selection box, it's a very top one, gives you an alarm list. Okay. You can further parameterize this alarm list saying it's active alerts, acknowledge alerts, or cleared alerts. I can explain a bit about this. So normally, if you do it all automated, an alert goes to active state. If you pick up the phone, put it down, goes to cleared state, nothing in between. But there's also a notion of having more like a manual interaction. So if something goes wrong, let's say the traffic sign is tilted, someone needs to go work on it. So we send it to acknowledge state. If we know this is going on, we're going to work on it, and then it's going to be cleared once it's okay. So we're going to just say we're just interested in active alerts for now. We'll just leave alarm types as is, but make sure it's your asset that's here. So it's by default because we're in our specific devices screen. So no alarms to display. If I pick up my phone, you'll see now the alarm list here shows. So we have more richness to our operational dashboard. You can also see that I'll be able to acknowledge it from here, and it will stay on, but it will go to acknowledge state. So we're not seeing that. So we could add like another one here, saying another alarm list. This is just for visuals, right? So you don't even have to do this, but you can. And same, just using acknowledged ones. And it's gone down because we've already switched back to the G's. Let's just straight away do another one while we're here. And now we also have like the historic alerts, which are the ones that were cleared. Right, so we just said cleared, the other ones, disable the other ones. And now you see the historic alerts of my phone. Okay, but just to go through the motions again, I'm picking up my phone. I say, okay, I see that you picked up your phone. I'm going to acknowledge it. You see it was acknowledged alert, so there's alert going on. Also, what you see is there's now 3 measurements being received while it was already in alert state. So it's 3 times it happens that it's gone too high. So you won't get 3 different alerts because that would really clog your dashboard. It's just the same alert and multiple events will happen on it. And then as soon as you put it down, it goes to the cleared alert list. So this is really all about the basics of alarms. So we'll be able to do this, I hope. And you're good, Jurjen?
Yes.
Okay, cool.
So, can I get a message on my phone when your phone is picked up?
Yes, you could. Yeah, and I'll explain about this. This is really the bridge to the, let's say, more in detailed analytics part. So it's a really good question, actually. It's almost like we rehearsed it, but it wasn't. It wasn't. Crazy. Okay, so yeah, just to give you a bit of an idea about. Just a while. I think a big truck is just entering the building. So sorry for the noise. Yeah, so this is where I need to show you a bit about let's say the next level of analytics. I need to prepare one thing on my other screen here. Hang on. Yeah, just to be able to make sure nothing gets broken. Just give me 1 second. I hope everybody's still with me, and that the guys online will be able to help you out wherever necessary. So this is just to show you what you can do is you can look at next level analytics, right? So you've seen the smart rules, right? And it has some very interesting stuff already. I'll come back to your question just a bit later. So what you have is you can set other smart rules. So just one thing I wanted to show you here before we move on. So one, you see more rich, if you not take it from this data point, you could also use other input from the device as interesting ways to create an alert. So we can do here, you don't have to do this yourself, you can just follow my lead, or you can just see what I'm doing. Just to show you can do like also geofencing. This is typically something that's pretty hard to do. And we can say, okay, on geofence create alert. So what happens if, let's say, my phone enters this building, I want to have an alert, or if it leaves the building, right? You have your assets in your building, if they get stolen, they move outside the building, that's not what you want to have some kind of alert going on. So let's say I want to edit this geofence here, and I take an address, and this is the really cool thing about this location. If anywhere in the world you search for RDM, you actually end up right here, which is, I think, is a really cool thing to have, right? So it will take a little time to build up the map, but this is the actual building we're in right now. So actually, it's this one, right? So the RDM campus building. So let's say if I have this parameter here, and just take an easy square here, and I'll just save this as a geofence. What would happen now is that on leaving or entering, or both, you'd get an alert. What alert? Again, you can configure here. It's a geofence alarm. You can set it to major, minor, whatever you want. So it's geofence violation. So if I leave this on and I take my phone outside when we're done with the meeting, this our platform would show this geofence alert. Right? You can do anything with it. So just wanted to show you like a bit off topic. So as the next level of stuff you can still do with smart rules. It's still very low threshold. You don't really need too much knowledge to do this. And then you can move on to the next bit in analytics, which is really combining measurements from different kind of sources. And for this, you could look at the analytics builder. So I haven't explained to you a bit, but what you have here on the top is your app switcher. So any applications on the platform you have available, you can work with, right? So we have, for instance, we have the IT education package where you can get like a quick start. We use it for onboarding new students here. And also the analytics builder, which is like the next step in analytics. So it's all about real-time analytics still. And it shows you more of what you'll be able to do. So one thing be able to do is device test alarm to phone message, for instance. That's what you want, right? So I have a device. I'm not going to spend too much time on this, just for time reasons. I'm going to show you this, and it's really I get a test alarm from a device. Let's say it's my test device. Could be your phone, right? And then I could send a message to my phone or another iPhone, saying, okay, this is a test from this smart rule. So this is just a very simple one. So actually, what you requested is a very easy one for these smart rules to do. I can show you a bit more about, let's say, if I want to have a more, let's say, if you want to have an event to measurement scenario, you already have like different buttons and stuff that's working. Combining, doing measurements, maybe creating, doing calculations on it, and come to some kind of output. And even what you can be able to do is, in the later versions we have, is the ability to add machine learning to it. So imagine that you're accumulating all this data from all these sensors across your ecosystem, and then you could also, let's say, offload all this data to, let's say, a data lake, and you can do like traditional BI on it, or create machine learning algorithms, so models on it. What you can do is you can take your the model you've learned from your historical data, you can put it back into the real-time analytics part of, let's say, the fast track we are showing here, and you could apply this model to your live input to make sure you do your machine learning and do the right stuff with the data coming in. So really, it's all about the granularity and a fine-grained way of making sense of your data, right? So that's stuff you could do. One other example here, say event measurement to event, for instance, it's a bit more complex again. So you see this happening. a customer that I think it's Dürr in Germany that creates smart painting cabins for car manufacturers, right? So depending on the color you make and the material you have and the type of car and the environmental circumstances like humidity, for instance, you could actually change the mix and the way the nozzles spray the paint onto the cars in real time. So actually Dürr is using this kind of models run from these Apama Analytics Builder blocks to actually do this in real life. So it's really a good example of that. So I think this has covered the analytics part mainly. So next thing I would want to do is to actually go about and show you about the next part, which is the way we can have our we use our alarm to actually connect to the outside world, right? So I'm going to go back to we can all go back to the cockpit. And we remember we have our group's smartphones, nope, phones, and go to your own phone again. And remember we did the alarm thing, and hopefully we still have the smart one enabled, which is really important for the next step. And just make sure we set the threshold right and the phone picked up thing is happening. The reason why this is so important is that we're going to use our external integration logic to actually use this phone picked up one with the custom text that you created for your individual device, and make sure this lands in the service management part, so the mechanic really can go out and fix the traffic sign. So just to give you some idea about this, we've already shown it in the overview. We have a project for the Cumulosity workshop we're doing today, and it has two processes in it. One is alarm to service ticket. So you don't have to do this hands-on. It's really just to show you how it's done. If I look at this process, what you'll see is that there's an integration process that really does nothing else than listen to alerts coming from the platform. And I'm just going to show you a bit. It connects to RDM Next, so it has like a standard set of connection credentials to do. It will listen to any device, so all of your phones creating alerts will be able to come in. And then I have some logic to switch if it's like a phone picked up event and it's a newly created one or not. And only if it's a new phone picked up alarm, it will go to, in this case, ServiceNow and create a ticket. So it's now switched off, so I'm going to switch it on. This is always the interesting part. It should be real time. So now, if this alert gets created, I'm going to pick up my phone. What should happen is that the integration flow kicks off, creates a ticket in ServiceNow, and logs it that it goes okay. I can check back here, create incident, log incident, created. Looks like it's all being done correctly. It's fine. So you see a phone picked up event coming in, so you have all like the low-level details of the integration process to show that this all went fine. So on the last bit, what we'll see is that we'll be able to show you is if I get the right. Yeah, I need to move this. That's a bit of a pain. Hang on. Yeah, I'm going to ServiceNow here, and I'm going to log in as my integration user. And what happens is that you'll see, if I refresh the screen, you should see a new incident called incident 17 being created, and Jan's phone was picked up. Right, so now we have the service management people knowing that the traffic sign has been toppled over, and somebody needs to go out and do something about it. Right, so there's one last thing I wanted to show you about this integration process, and that's actually the other process I prepared, and that's really to do some kind of feedback from the service management system. Right, so accidental saving, and I have ServiceNow alarm update. So if I look at this, I need to go here. What you'll see just very quickly is that it will it will listen out to ServiceNow updates, so from the service management tooling, and then it will check if it's an update on a specific incident. It will have like the correlation ID from the alert. I forwarded this one to the actual service management tooling, so any update will be able to relate back to a certain alert being created. And what we'll do is I'll acknowledge the alert as soon as you start working on it, and I'll clear the alert as soon as the alert is resolved. So typical workflow would be, I'm going to, okay, I see that this phone is being picked up, or the traffic sign is being toppled over. What you'll do is I'm switching it from new to in progress. And if I then update the ticket, it will go to in progress, and the same flow will actually go. And in my cockpit, you'll be able to see in the dashboard that an alert should go from alarm to, let's say, from actual to acknowledged. This is like a process that runs every 5 minutes, not real time. So we're not going to wait for it today, but you can rest assured that this happens. And the last bit you do normally is you go into, oh, you see there's 2 other incidents created. Cool. Let's just have a quick look at that. So GP's phone was picked up. Very nice to see you be able to follow through this whole list, and even more. So all of you have been doing great. So what I'll do is I'll just finish this one up and resolve the issue. I need to take a resolution parameters in, saying okay, it's solved as a workaround. All okay, fine, and then resolve it. So phones are going to be put down, and the statistics work here, and my cockpit will say, okay, no alarms here, and it was all cleared. So this really concludes the hands-on part. I hope you've been able to follow through. I'll have a quick look at the chat window. I see you're all good. So yeah, I'd really like to thank you for seeing this. I hope you have kind of a good insight of what an IT platform could bring, how the combination of sensoric information in the IoT platform in relation to the real world systems outside, in reconnecting to the devices in themselves, can add true value. So I really hope this triggered your thought a bit about what's possible and what would be able to be the next steps for you personally. So that's what we'd like to do, from a joint venture from IoT Academy and Software AG, to really pick this up and make sure we be able to spar with you and exchange some thoughts on what would be logical next steps for you to take. So I think this is about it. You would like to close off?
I just grabbed
grab my camera.
So I was sitting behind Jan's screen, and I've been playing along with the
dashboard,
with the dashboarding and all the alarms and everything. So yeah, so I hope that the concept of IoT, with which we started this whole session, to measure something in the physical world, bring that to the internet, and then do something with it to really generate value. I hope that became clear. It also it sparked some ideas of what you could do with it, how you could implement it in your own processes and projects. The sky is the limit here, as you see. I mean, now we have used very expensive phones that only work if you have the app active. But of course, you can make your own translation to small devices specifically for your use case, designed and built using the type of connectivity that you need, and also then on the platform side, connected to the data silos you use, the software vendors that you have in place in your factories, in your systems, anything. And it can all be added to your current business and the way you conduct your business. And as Jan also already said, within the IoT Academy, we have a couple of types of workshops, brainstorms, in which we can help you to go from this information to ideas how this can be implemented in your own organization, your own projects, in your own processes. And If you want to do that, just get in contact with Gertild or with Jan, and then we will arrange a specific brainstorm with your organization. So everything is private and will stay private, and really to explore possibilities for you. So thank you for your attention. And I don't know, Jan, if you have any last thoughts, any last.
No, I'm really, really excited that you stuck with us for the session. Really hope you learned something, and I'm looking forward to stay in touch later on. Okay, so that's it. I'd like to close off the session. Jurjen, thanks again for having us, and speak to you soon. Okay, bye bye.